Hello coders, welcome to my channel. I am Aniket and today we will be discussing the problem from GFG, that is non-attacking black and white knights. Let's read the problem. Given two integers n and m representing the dimensions of a chessboard, find the number of ways to place one black knight and one white knight on the chessboard such that they cannot attack each other. So, in what condition they attack each other? First of all, I would like to introduce the knight moves towards those people who don't know how to play chess. So, if the knight is here, then it can go two moves right and one moves up or one moves down. So there are two positions where this k can go. Similarly, this k can go one moves right and two moves up or one moves right and two moves down. So this can go up this k dash and k dash. If we do indexing, so let's say it is I comma j, then if it go k dash, then the new I will be I plus 1 because it increases by 1. No, this is not increases by 1. This is increases by uh, I is increases by minus 2 because you go up, and j increases by 1 because the column is increases by 1. Similarly, here also I is increases by 2 and j is increases by 1. I hope you got this how this indexing comes. And similarly here also k dash value is I is increases by uh, minus 1, I is decreases by minus 1 and j is increases by 2. You go to plus 2 column and minus 1 row. Similarly here also I is increases by 1 because you go to down, and j is increases by 2 because you go to the right. Similarly you can do the same in this case also, like two moves left and one moves up, you reach to k dash, and the index to this is I minus 1 and j minus 2, and here its index is I minus 1, I plus 1 and j minus 2. Similarly here also, if you move one move left and two moves up or down, you reach at k dash, and here also the index is I. What is the value of I? You go to the two moves upward, so I minus 2 and j minus 1 because you go one move left. Similarly here also I plus 2 and j minus 1. I hope you got this how the this knight can go up to this k dash k dash k dash and all of these 8k dash. It can easily seen that this knight can go up to these 8 positions only. Many of the people say that you consider this move horizontally, what happen if you consider this move vertically, like one move upward and two moves left or two moves right, one move upward and two moves left, then one two moves upward and one moves right, and two moves upward and one moves left. So you can easily see that vertically you will reach at the same position as you already reach by this horizontal. So no need of this vertical, no need of this vertical move. You can easily go to any possible move through this horizontal traversal. No need of doing this vertical move of uh, this knight. I mean that you don't move to one move upward and this type of move. Like I mean you only do horizontal uh, move and go to upward, and this is similar symmetrically to the vertical move. So you only consider these 8 moves, like this one move and this one move. There are possibly there are 16 moves for a knight, but 8 of them is symmetrical to other 8. So you can do only this type, these 8 moves. You will reach at all possible, you will reach at all possible spaces or positions where this knight can go up to one move. So if you carefully see that in one move, how can you find that these two knights are attacking? So first question is, how can you find that the two knights are attacking each other? So this is very simple. If you carefully see that corresponding I and j difference, it can be either 2 comma 1 or 1 comma 2. So if you carefully see the difference between I corresponding I and j for k and k dash, it can be 1 comma 2 or 2 comma 1. Like in this case, if you do this k to this k dash, then the corresponding difference is 2 comma 1. If you go from this k to this k dash, then the corresponding difference is 1 comma 2 between this corresponding I and j. So it can be easily figure it out which knights are attacking each other. I hope you got this. How can you find that which two knight are attack each other? So let's discuss its brute force approach now. How can you do it with brute force? So in brute force, what you do, for every cell of A means first knight, you traverse every cell of B. B means second knight. So after you traverse, this will give you the all possible pair of cells A comma B, where A is the first knight and B is the second knight. A is the black knight or B is the white knight. So it can be easily it this loop, this nested loop will generate all possible pair of cells A comma B. After getting all possible pair of cells A comma B, you will check whether A is not is equal to B. If A is not is equal to B, then you will do the same. Then you will check whether they attack each other or not. I already discussed how can you check the attacking, because the corresponding difference between corresponding I and j for A and B should be 1 comma 2 or 2 comma 1. So in this way you can easily check you can easily check which two knight are attacking each other. If you found any pair that those two knights are attacking, so you will increment your attack. Since you want to find non-attacking uh, non-attacking possibilities. So what you can do is you will do total minus attacking possibilities. It will simply give you the non-attacking possible pairs. Like in this question says that you have to find that all number of ways in that the two knights doesn't attack each other. So in those cases you will find the total ways of placement of those two knights, and you will subtract it to the attacking possibilities, uh, po- all number of ways in which you place two knights and they attack each other. So you can simply do attack plus plus, and this attack can simply subtracted from the total. How can you get the total number of ways of placement of these two knights? So total is simply that n into m into n into m. This is simple combinatorics which is of 11th class. So n comma n into m is the ways of placement of a, and if you place a, there are only n into m minus 1 ways for placement of b. So there are total of n into n into m minus 1 possibilities for placement of these two knights. I hope you got this, how you got this total value. And why I checking I is not is equal to b, because the question says that the knight have to be placed on different squares. So if the cells are same, so why I will check these conditions. I will check this condition only if the cells are not same, it is distinct. This will signify this is distinct. So in this way you can easily check whether the out of all possible pairs of cell whether they are attacking each other or not, by this condition that the corresponding difference between I and j should be 1 comma 2 or 2 comma 1. So let's discuss its time complexity. What is the time complexity of this approach? If you carefully see, for every cell of A, you need there are n into m cells, and you traverse for every cell of A, you traverse every cell of B. So there are also n into m again. So this nested loop will give you n into m into n into m. So this is the complexity for this approach. If you carefully see, this will result you to n into m whole square. So since the problem constraint says that n into m should be lesser than equal to 45,000, and if you do n into m whole square, then 45,000 whole square in worst cases is greater than 10 raised to the power 8 operations. So it will result you a TLE condition. It will result you TLE. So you can't do this brute force this brute force method according to problem constraint. So you have to do any optimal solution. If you carefully see this condition, it is worth it to check this for every cell of A, every cell of B. My question to you that is it worth it to check every cell of B for every cell of A? The answer is no. Why? Because knight can only do 8 type of moves. Because knight can only do 8 types of moves, which result into 8 distinct position. So why you are checking all every cell of B? You should check only those eight positions where this knight can attack to those eight positions. So how can you find those eight positions? So this can be easily find using a dir two-dimensional array. What is this two-dimensional array will store? It will store the direction in which the knight can move. So if you carefully see the direction, there are only eight directions: 1 comma minus 2, 1 comma plus 2, 2 comma minus 1, sorry 2, 1 comma minus 2 and 1 comma plus 2. And in this case you can easily see that there are eight directions. If you fill this grid table, then there are eight directions: 1 comma 2, 1 comma minus 2, and 2 comma 1 and 2 comma minus 1. Similarly here also minus 1 comma 2 and minus 1 comma minus 2, and minus 2 comma 1 and minus 2 comma minus 1. In this case you can easily see that, so there are eight directions in which you can move from one place. So you can easily use this dir 2D array in your calculation of next move. So let's say your move is I comma j. Then if you do plus it with this, so your next move can be I plus 1 and j plus 2. If you plus it with this, then your next move will be I plus 1 and j minus 2. If you plus it with this, so your next move will be I plus 2 and j plus 1. Similarly, I plus 2 and j minus 1, and I minus 1 and j plus 2, and I minus 1 and j minus 2, and I minus 2 and j plus 1, and I minus 2 and j minus 1. In this way, you can easily go from one specified position to any distinct position I minus 2, j minus 1. So there are 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 distinct positions. So for each I comma j of this A, for each I comma j of this first knight, you will traverse only these eight directions. You can go to I minus 2 j minus 1, or you can go I plus 1 to and j plus 2. This can easily seen in this diagram also. For a position I comma j, you can reach out eight distinct positions. So you can easily use this 2D did array to find the next possible position of a knight. So if uh, out of this position you will traverse, for every cell of A you traverse only these eight positions. So if you traverse this eight position, what happen? If you traverse these eight positions for every uh, position or cell of A, so what happens? It might be possible that it will result you the out of the chessboard. It might be possible that you get out of the chessboard. So you will only consider those uh, cells which are inbound. So you only consider those cells for attacking cells which are in the chessboard. So if you found any cell which is in the chessboard out of these eight, out of these all eight possibilities, so you can say that your attack can be increases. So the new method for this approach is, what is the approach for according to this? So approach is, for every cell of A uh, traverse all of the eight positions, and if positions are in the grid, then what you will do, you will do attack plus plus. Otherwise you can't do attack plus plus because your that knight will out of the grid, so how can it attack to the other knight? That's why you only attack plus plus if the position are in the grid. So this, if you carefully see the complexity of this this better approach. So the complexity is, for every cell of A, so there are n into m cells. You traverse all of the eight positions. So there are eight positions you traverse for each cell of first knight. This is of first knight and this is of second knight. So if it is inbound, then you will attack plus plus. Otherwise, you don't do anything. So the complexity of this new approach is O of n into m into 8. So it is easily acceptable because n into m is lesser than equal to 45,000. So it is easily acceptable. It is accepted according to problem constraint. So is it better way to do it in O of 1 or something better than n into m into 8? Yes, there it is a better way also. What is the optimal approach? Let's discuss it optimal approach. If you carefully see, in this optimal approach you can use formula. In this optimal approach we can use a formula to calculate the number of ways of placement of two knights such that they doesn't attack each other. So there is a formula. Let's formulate it, which result to you the complexity of O of 1. So for formula kind of thing, the complexity reduces to O of 1. So as you can see that the brute force approach will result you n into m, n into m in का whole square, which will give you TLE. So and you go to the optimal approach, then you when you go to the optimal approach the complexity goes to n into m into 8, and now this is optimal approach, which is O of 1. This is brute force approach. Brute force approach will take you, brute force approach will take you O of n into m whole square, and this better approach where you only traverse 8 possible directions. So it is O of n into m into 8, and this optimal approach is O of 1 only. So I hope you understand how can you how should you do uh, should you approach the problem such that first do it with brute force, and then it is a better approach, and then discuss optimal approach. Let's discuss the most optimal approach for doing this problem. But before that, please hit the like button and subscribe to the channel, because I consistently make such kind of intuitive video on my channel for you. Please subscribe to the channel. Let's discuss the optimal approach now. Let's make a grid. This grid containing 3, 4, 5. This grid containing 5, 6 rows. So n is 6, and containing 5 columns. So m is 5. If you carefully see that, let's say this is the A1, and what is the attacking pair of for this A1? This A1 can attack by this position, and this A1 can attack from this position according to the knight move of the professional chessboard. So this A1 can attack by this A2 and A2. Similarly, if you place here B1, then this B1 can attack by this B2 and this B2 and this B2. Similarly, if you place C1 here, then C1, this C1 can attacked by this C1, this C1, not this C1, this C1, and this C2 and this C2. If you see the 2 comma 3 rectangle, so what you will observe? So what the observation is, if you see the 2 3 cross 2 rectangle, you will find two attacking pairs. So in this case, as you can see that this A1 and this A2 is one attacking pair, this B1 and this B2 is another attacking pair. Since the arrangement is since the arrangement matters, because this can be white, this can be black, and this can be black, and this can be white. So the arrangement is matter. So there are four attacking pairs in each 3 cross 2 rectangle, and this can easily seen that if you consider 2 cross 3 rectangle, here also you got two attacking pairs. In 3 cross 2, in 2 cross 3 rectangle, there are two attacking pairs. If you consider the arrangement, so there are four attacking pairs in this case. So four attacking pairs for 3 cross 2 rectangle, or four attacking pairs for 2 cross 3 rectangle. So our next task is, what is the approach for this optimal approach? Let's write it. So first step is count the number of 2 cross 3 rectangles and 3 cross 2 rectangles. And let's say the count of these 2 cross 3 rectangle and 3 cross 2 rectangle is x. So because each rectangle contribute 4 attacking pairs, so you will simply do 4 into x. This is the attacking positions. So you want to find non-attacking positions, number of ways to place two knights such that they do not attack each other. So non-attacking positions are simply equal to total minus attacking position. So I hope you got this optimal approach also. Let's discuss the code of these three approaches. But before that, please hit the like and subscribe button. Let's discuss the brute force approach first. The code of this brute force approach. This is the simple code for Java which discussing about the brute force approach. So the input is the number of rows. This is representing rows and this is representing columns. So cells are the number of cells is simply n into m, and you can easily calculate total number of positions where you can place two knights. So you will initialize your attack to 0. There is no significance for this line in this brute force approach, so you can simply ignore it. And you will this nested loop is used for cell of a knight, that is black knight or white knight you can say. And this nested loop is used for cell of b knight. So for each cell of a, you traverse for each cell of b, and if it is not same, if it the cell are not identical, then you go to the next line, otherwise you will continue. So if you go to the next line, you will simply compare the corresponding difference between these two indices, I and x, I and x, and j and y. If those two indices difference is 1 and 2, or 2 or 1, 2 and 1, then you can simply increases your attack plus plus. And after that you simply return your total minus attack. But before that, please typecast your answer into int because the return type is int. So this is the brute force approach. This is the code of brute force approach. Let's discuss the code of the better approach, which requires O of n into m into 8. It is the code of BFS like structure. So let's discuss this code also. This is my Java code for the better approach, which requires n into m into 8 complexity. So if you see here, I initialize my cells to n into m. It is simple. I already explained you. I already explained it to you. I initialize attack to 0, and for each cell of A, for each cell of A, I traverse only 8 directions. I traverse only 8 directions, which will give me 8 distinct positions of the next move if I am at I comma j. So if you are at I comma j, you can simply use this 2D dir array to find the next move from this I comma j. So if that next move is out of bound, this condition check out of bound of the chessboard. So if it is out of bounds, then you simply continue, otherwise you will increment your attack plus plus. In this way, attack will store the number of attacking positions of those two knights, and you simply do total minus attack to get the answer. Let's discuss the optimal approach now, which requires O of 1 complexity. This is my simple Java code for O of 1 complexity, which is the optimal approach. This is very optimal approach according to problem, which require only a formula. So in this case, I already explained to you what is the number of cells and what is total number of positions in which you can place two knights, and how can you calculate this attacking ways. So you can easily calculate this attacking ways. Let's say there is this type of grid which is having this number of columns and this number of rows. So there are 5 rows and 7 columns. So you want to find 2 cross 3 2 cross 3 uh, boxes. So as you can see, this is the 2 cross 3 boxes. This is the 2 cross 3 boxes. So what is the number of these 2 cross 3 boxes in this grid? This is simply 1, 2, 3, 4. So that is 4 into 1, 1, 2, 3, 4, 5. That is 5. So how can you find this 4 into 5? There are 20 boxes of 2 cross 3 size. The simple formula for finding 2 cross 3 boxes is simply n minus 1 into m minus 2. This will give you the number of 2 cross 3 boxes. Similarly, you can find number of 3 cross 2 boxes also with this formula n minus 2 into m minus 1. It might be possible that it will result you the negative number. So do you multiply it negative number? No, it is not optimal. So you do 0. So you will do this statement math dot max of 0 comma m minus 2, because minus 2 can result you minus 1 also. What happen if m is equal to 1? In that case, if you do 1 minus 2, it will give you minus 1. So it is not good to you take this minus 1 multiplication with n minus 1. So you will do only 0. So that's why I use this statement math dot max of 0 comma m minus 2. In this way, here also I use 0 comma n minus 2 math dot max of 0 comma n minus 2. So this will give you the number of 2 cross 3 boxes, and this will give you the number of 3 cross 2 boxes. So after getting all number of boxes, you will simply do a 4 multiplication by it. This will give you the total attacking pairs, total attacking ways, and after that you simply do total minus attacking ways and return your correct answer, in which the total number of ways in which the two knights will not attack each other. So this is the final answer, total minus attacking ways. I hope you liked my explanation of for this problem and how I approach this problem from brute force approach to better approach, and better approach to optimal approach. So please considering a like and subscribe to the channel. Thank you for watching my video.